So what we're going to do after we strip forms, concrete's been poured, anchor bolts have been cast in place, we're going to get our mud sill and we're going to mark it out and we're going to drill holes where the anchor bolts are and we're going to slip the mud sill over the top of those anchor bolts. Okay? We'll talk more about that in another lecture, but what I want to talk about is the washers that go over those anchor bolts. Okay? They're very specific washers that we're supposed to use. They're 3x3 by 1/4 inch thick steel washers. I didn't mention the diameter of the bolts either. The bolts are almost always 5/8 now. They used to be 1/2 inch. I can't remember when they changed this, but they're all 5/8 now. They also used to use these tiny little washers to go over the 1/2 inch bolt to bolt down to the mud sill, and they've changed that now to these 3x3 washers. Okay, and again, when the codes change, it's usually a reaction to something that's happened. Okay, they saw, well, that didn't work. Okay, we need to change that. And so I've taken apart old houses where they had 1/2 inch bolts with tiny little washers, and the mud sills just will pull right through it. Okay, there's not enough surface area to prevent the mud sill from just pulling right through that bolt. Okay, so we need that big 3x3 washer on there. This is a slotted washer, the same idea, 3x3 washer, except it's slotted. So let's just say, for example, you don't end up with your anchor bolt exactly centered on the mud sill. Okay, what can happen is your 3x3 washer can stick out past into the exterior, in which case you'd have to like grind part of it off or notch the plywood around or something, or the other direction, it could stick into the inside. You have to notch the drywall around it or something like that. But what you can do is you can get these slotted washers and you can place those on top of the anchor bolts, and then you have a little bit of travel with that washer to move it kind of laterally and make sure that it's going to stay in the bay. The one trick with these things is if you use that slotted washer, you have to put an additional fender washer on top of that slotted washer and then tighten your nut down on top of that. Okay. Our anchor bolts are always going to be galvanized because they're coming into contact with pressure treated lumber. Okay. I already mentioned that we need to lay out the walls or the floor joists depending on what kind of foundation we're doing, but I just can't emphasize enough how important that is. We are going to be using engineered floor joists. So if we're going to be pouring a perimeter foundation and we're going to be using engineered floor joists, we cannot alter those floor joists at all, with very few exceptions. Okay, and we'll talk more about this in the floor framing lecture, but if we were using standard dimensional lumber and it landed on a joist, or excuse me, an anchor bolt, maybe it wouldn't be such a big deal to notch a little bit out of the side. Okay, if we're just using 2x6s or 2x8s. But if we're using engineered joists, the I-joists, we can't cut into that web at all. We can't notch around it. The structural integrity has just been destroyed by the time we do that. Okay, so carefully lay out all of the anchor bolts so that they land between the studs, between the floor joists. They're not going to be in the way. Okay. The other thing we need to consider is if our house is bigger than 20 feet in any direction, we're going to need to splice the mud sill. Okay. So a couple rules here. It doesn't matter how long our mud sill is. If it's 12 inches long or 20 feet long, we have to have a minimum of 2 anchor bolts. Okay, so if we have a tiny little section of mud sill, we still have to have 2 anchor bolts no matter what. Okay? If we have a longer piece of mud sill, most of the time they're not going to be able to be more than 72 inches apart. Okay, that can change though. I would say almost every house has one wall where the engineer has determined, we need a little more shear value on this wall. I'm going to increase the anchor bolt spacing. Okay, so maybe on certain walls, the anchor bolt spacing is 48 inches on center. Okay, and you remember that from the plans, that little diamond that has the shear wall edge nailing on the bottom and the anchor bolt inches on center spacing on the top. Okay, that's how we determine what that anchor bolt spacing is. Okay, so when we're placing our anchor bolts, not only are we laying out for joists or studs, we're planning on where our splices are going to be, where our pieces of mud sill are going to go, okay? Because we have to be within certain parameters at the end of that mud sill. Okay, so wherever that mud sill ends, we can't have an anchor bolt farther than 12 inches from the end of that mud sill, okay, from the butt end of that mud sill. We can't be any closer than 6 inches to the end of that mud sill. Okay? If we're farther than 12, there's not enough holding that end. If we're closer than 6, we're weakening the end of that board by drilling a big hole through it. Okay? So our magic number that we're trying to hit is 9 inches. Okay? We're going to lay out our section of mud sill, and we're going to try and place an anchor bolt about 9 inches from the end, because that's a nice cozy in-between number. Okay? And if it's going to be too close to a joist or too close to a stud, we might have to maneuver it around a little bit. Okay? The other thing we want to consider is, let's say we have a wall that's 21 feet long. Okay? Our natural tendency is to just put 20-footers everywhere. Let's get the longest boards we can and put them in. Okay? But that would be a 20-foot board and a 12-inch board. And then when we're trying to put 2 anchor bolts in a 12-inch piece of mud sill and be 6 inches from the end, that's going to be a real problem. Okay, so we kind of want to plan the lengths of that mud sill out a little bit. So there's a lot to think about. There's a lot to plan out when we're doing this, but a little bit of time invested before we pour concrete it's going to save us a lot of time in the long run. Okay, it's a lot easier to change things and plan things out and fix things before our foundation is in place, before we have a giant piece of concrete. Okay. All right. Hold downs don't appear on every house, but it's common to have some hold downs on a foundation. Okay, and these are going to be clearly depicted on the plans. Okay, so let's back up a little bit and we'll talk about, like, remember when we talked about the compressive load and tensile load and shear load on a building. Okay, we're going to counteract that shear load with a 4x8 sheet of plywood. Engineers love being able to see that there's a 4x8 sheet of plywood going on the wall. Okay, that gets complicated when we have windows or big doors, because those full continuous sheets are interrupted by a window or a door, and they don't have the same holding power. Okay. The most common example, the most common places that I encounter these hold downs are usually on the sides of the big garage door. Okay, so we have a wall, and that wall is getting blown against with 40-mile-an-hour winds, or there's an earthquake pushing against that house. Okay, the opposite wall, or the adjacent wall, I guess is a more appropriate term, the adjacent wall to whatever those loads are being applied to, that in theory is completely sheeted off with plywood. So that wall is not able to lift up. Okay, it doesn't have anywhere to go. But when we take out a bunch of plywood and put in a big door, there's nothing to resist those loads on the other side. Okay, so let's say, common garage door size, garage wall dimension is 24 feet wide. If we have a 16-foot door in that garage, that theoretically leaves 4 feet on each side, but that rough opening's a little bit wider, and that whole wall has been interrupted by that big door. So most commonly what I see is these hold downs on either side of a big garage door, or maybe we have a big window or something like that. I'll see hold downs on either side of that big opening, okay? What these hold downs are composed of is a really big bolt. This is called an SSTB, a Simpson strong tie bolt, and the length varies. The engineer will determine how long this thing needs to be in order to counteract the loads. So this is an SSTB 16. It's a Simpson strong tie bolt, 16 inches long. They have SSTB 18s, 20s, 24s, 36s. Okay, whatever you want, you can get an SSTB that length. This gets cast into the concrete, and imagine trying to rip this thing out of the concrete, okay? This is pretty significant. This gets very carefully laid out, okay? Because this has to have a hold down placed over it. An HD stands for hold down, and the most common one is a U2. I can't remember what the U is, but there's HD U2s, HD U4s. This slips over the bolt. It has its own special washer and gets bolted down to the mud sill. Okay. You have to have a double stud for this hold down to bolt into. Okay, so let's pretend, let's go back to our garage door example here, or a window or some big opening like that. This is the big opening over here. And then we've framed a trimmer, which is going to hold up the header. You might not know what I'm talking about yet, but we'll get to that eventually. And we have to have 2 full height studs in that wall for this hold down to bolt to. Okay, so again, we've got our form boards in place. We're laying out the whole wall on those form boards and seeing where everything needs to go. And if we have hold downs on our plans, we need to lay out where the framing is going to go so that we have enough room to slip this hold down in for the strong tie bolt. Okay, I mentioned before that let's say we miss an anchor bolt or something like that, we can come back with a Titan bolt and drill that in and drive that thing down and hold the mud sill down. Okay, we don't have that option with these SSTBs. We can't come in and put a Titan bolt down and expect it to replace this SSTB. For one thing, this thing's 16 inches long and it's got these loops on it. Okay, we can't really replace that. This would be a significant engineering fix if we screwed this up, or it'd be we'd have to change the size of our window or something like that. It would be a big problem if we screwed up this placement. So this is something that needs to be pretty carefully placed. Okay. The other thing I'll note about this, and just remember this when we're nailing off our plywood, these double kings are going to be nailed with edge nailing, perimeter nailing with our plywood. Okay. Again, back to that little diamond that we're going to see on our plans. The top number is the spacing for the anchor bolts. The bottom number is the perimeter nailing on our plywood. It's usually 6 or something like that. These studs that the hold down is screwed into are going to get edge nailing. So 6 inches on center, edge nailing into these double kings. Even if it's in the middle of the sheet, it doesn't matter. These are going to get perimeter nailing.